Alright students, today we look into properties of similar figures in lesson 7-4. In our last lesson on 7-3, we looked at similar figures and determined if the shapes were similar. Talked about the transformations that it would take to make those two shapes similar. Now we're going to start looking at the properties of similar figures. What can similar figures do for us? Similar figures are used very often in scale models. Like blueprints, or an architect will build a scale model of a building that they want to build in order to show the detail of that new thing, because you can't just build a building just to test it out. So we're going to see today how similar figures, how we can use the numbers in them and how we can make the shapes larger and smaller. And we're also going to find missing sides of those similar shapes as well. So let's take examples. Here we have a pair of right triangles, and we're supposed to determine whether they're similar or not and why. So here's how we can do this. There's a couple of different ways to go about this. First way we can go about it is we can do what we did in our last lesson, and that's test the ratios. We can start with the bigger triangle and take the hypotenuse and the hypotenuse that would match up, and we can say, okay, do these match up? I don't know, 17 over 13. Does that equal something like, for instance, 15 over 12? And we can test to see if those are equal. And we can test 8 over 5 as well, and we can see if all those are equal. Well, the answer to those questions is no, these are not all equal. When you divide 17 divided by 13, 15 divided by 12, and 8 divided by 5, you get different answers. So these are not similar, because the ratios don't match up. They just don't work. So that's one way of going about your business and checking. There's other ways to do it as well, so let me show you on this other example how you could go about this. You have two trapezoids here, and we want to find out if they're similar. You can use sides that would go together. How do you know what sides go together? You base it off of the congruency marks. So the side between 1 and 2 would go with the side between 1 and 2. And the side between 1 and 4 here would go with the side between 1 and 4 over here. So let's set up a proportion. Now you guys remember a proportion are two fractions set equal to each other. And we're going to test this proportion to see if it's true. So we have a proportion like, let's do little over big. So we're going to take the 5 and the 15, and they go together. So we're going to make them a fraction. They go together because they're the same side of the trapezoid, just on the two different shapes. We put an equal sign between them, and we're going to use the other two. Now the 8 goes with the 5, so we're going to put that on top. And why does the 8 go with 5? Well, obviously they're on the same shape. And then the 24 is going to go on the bottom. And the 24 and the 8 go together because they're here and here on the red side. And the 15 and the 24 go together because they're on the same shape as well, as you can see here. So, how do we test a proportion to see if it's true? Cross multiply. We're going to cross multiply these two numbers and see if they equal each other. If they equal, then the two shapes are similar because the proportion works. If they don't equal, then they're not similar. And that banging you heard was my heater turning off here at the house. So 5 times 24 is 120, and 8 times 15 is also 120. So what we find out is check these two proportion. This proportion is true, which means these two shapes are similar. Okay. When it says explain here, let's just use our work to explain it. Okay. If we need to use words, over here we would say they're not similar because the ratios are not equal. So I need to make sure I show that by putting slash marks through the equal signs. And on this side, these are similar. And again, the words would be because a proportion is set equal, or you could show your work. Okay, so that's the first part. You need to be able to show if shapes are similar or not using their sides. Now when we come down here, our job is now, we don't have to find out if they're similar because it tells us very clearly each pair of the polygons is similar. What our job is now is we have to find a missing side measure. Now, there's two ways to go about this as well. The first way, my favorite way, is to set up proportions. Proportions, for me, work all the time, and I don't have to think about them, but they do sometimes trip students up when they set them up. So let me show you how to do this the right way. So everything we've learned so far has been about transforming these triangles and seeing how they would match up. Hopefully you can see in these right triangles that 5.6 is the hypotenuse and x is also the hypotenuse. So those would match up, those would go together. Another side that goes together is this 4 here and this 10 here. So you can see I'm using color to show what sides go together on the two different triangles. This will help me as I set up my proportion. So I'm going to use the two blue sides, 4 and 10, as the first fraction in my proportion. And then I'm going to use the red sides. I'm going to put 5.6 on top because it goes with the 4, because they're on the same triangle. And I'm going to use x on the bottom because the x and the 10 go together because they're on the same triangle. And the 5.6 and the x go together because they're both hypotenuses of right triangles. So now we have this proportion. And what do we do with this proportion to solve? The most famous 4 words that I can ever say to you: cross, multiply, and divide. Say that again: cross, multiply, and divide. Cross, multiply, and divide. Right here. So what we do is we cross multiply. So we do 4 times x, which is 4x, and 10 times 5.6, which is 56. And now we have a one-step equation to solve. And how do we solve it? Well, if we cross multiply, now we divide. So we're going to divide by 4 on both sides, and we end up with x equals 14. So then that means this x equals 14. And it would be whatever units the measurement is, or whatever units the shapes are measured in. In this case, we don't know, so we would write it as 14 units. And that's it, and that's all, everybody. That is all there is to it. You cross, multiply, and divide. The key to this part is you have to set up the triangles correctly. Notice the use of color. I strongly suggest you do the same in your practice problems. On a test, you'll have a pencil and a highlighter or a marker or whatever you want to use. So please, use color, help yourself out, make it the best you can make it. Okay? Now, well, hello there. Okay, now, what we have the rest of the way here is, let me get rid of a little bit of work here, so we can kind of get rid of it here. Okay, now we got that all cleaned up. Let's go ahead and take a look at another problem. Let me show you a different way to go about this. Another way you can go about this is you can decide to figure out what the scale factor is. You know that they're similar, so you know they have a scale factor. So you can think, okay, here's the side, the red side between 3 swoops and 4 swoops. Here's a side that's between 3 swoops and 4 swoops, it's x. So we do not know exactly what the scale factor is. So let's look at a different side. We could go between 1 swoop and 2 swoops, and that's 3. And we can go between 2 swoops and 1 swoops on the big one, and that's 6. So we can think, how do we get from this bigger shape to the smaller shape? How do we get from 18 down to x? Well, on the blue sides that are similar, you go from 6 to 3. So your thought here is, what can I divide by or multiply by? Now obviously, these numbers are getting smaller. To go from 6 to 3, the numbers are going to get smaller, so that's a division problem. So 6 divided by what gives you 3? Well, the answer is obviously 2. So the scale factor here for this problem is 2. That means all of these numbers on the bottom, when you multiply them by 2, guess what? You get the bigger numbers on the, oh sorry, that's down here. You get these numbers that are on the other shape. So then our thought is, what times 2 gives me 18? Or 18 divided by 2 gives me what? Hopefully you can figure out that that's 9. Now you can think about it that way, and that's not a problem. But the key to this is they're not always going to be nice, easy things like 2. Sometimes the numbers will be 2.5, or 2 2/3, or 4.67777. And the last thing you want to do is get caught up trying to think, well, what divides, or what do I multiply by, or what do I divide by to get from there to there, and it not be a nice even number like 2. So I suggest the proportion method that we did on this triangle problem. And if you need those tips again, just rewind the video and go back to it. Or you can think, what is the scale factor? If it's something easy like 2, roll with it. As long as you show me what you're doing, I really don't mind whatever way you choose to do it. Okay? So there's a couple more practice problems here. You're going to have plenty of those in your book. I do want to show you this. I do want to show you this application problem, though, this tiles problem, because this is where we want to go. You have a blue tile. Well, I should probably circle in blue, huh? We have a blue tile and a red tile. They're similar. The blue tile, it has a length of 10 inches and a perimeter of 30. And the red tile has a length of 6 inches. What's the perimeter? Well, guys, if the shapes are similar, then the lengths are similar, and then the perimeters are also going to be similar. So as you can see, we have this all set up for us. We have the lengths right here. We have the perimeters here. We have the blue tile matching up here, and the red tile matching up here. This looks just like a proportion. So we take out all the letters and equal signs. We get 10 over 6 equals 30 over what? Cross, multiply, and divide. Cross, multiply, and divide, we'd have 10. Let's call this x instead of question mark. 10x equals 180. And if 10x equals 180, cross, multiply, and divide. You divide by 10, and there's x equals 18. So the perimeter of that shape, that red tile, must have been 18. So this is something that you can do. This is something that you can work with to figure out these things. Now on this problem, trying to figure out the scale factor is not easy. The scale factor is actually 1 2/3. I don't know about you guys, but I don't really want to try to think of 1 2/3 as my scale factor. So the proportion always works. Cross, multiply, and then divide. Okay? So those are your properties of similar figures. You see here we were able to use similar figures, or we were able to determine similar figures by using ratios like we did in section 3, and by checking proportions. And we were able to use scale factors and proportions to determine missing sides. And then we were able to use our knowledge of similar figures to work on a problem like this. Lengths and perimeters and stuff like that are all proportional. So that's the end of lesson 4. All right, so good luck on your work. If you have any questions, let me know. Appreciate you watching. All right, let's get after it.